Okay, so today what we're going to do is we're going to look at multiplying algebraic terms. Last time, the last couple of lessons, we were combining algebraic terms, and that's add or subtract depending on the signs, right? But today what we're going to do is we're going to look at how to multiply algebraic terms. And the key phrase here, the key thing to remember here when you're multiplying algebraic terms, there are two things. Your first job is always to identify the operation. Every time you change operations, in algebra or arithmetic, it doesn't matter. If you don't know what operation you're dealing with, then you're never going to come out with the correct answer. Okay? So you have to make sure. Yeah, I just changed it. Hold on. So always make that your first thing that you do. See what operation you're dealing with, and then you can apply the rules. It also helps because it makes you slow down and think a little bit about what you're doing. All too often we just jump into something and don't pay attention to what it is we're doing, and then we get it wrong even though we really knew what we should have been doing. Okay? So be careful about identifying the operation. And when you're talking about operations in algebra, remember that there are several ways that multiplication can be written. You can still see the x used for multiplication. A lot of times I will slip into that dot. So remember that dot and the x are the same. You can go ahead and correct me if you like. If you don't like the dot, I'm happy with that. You can have a bracket, and as long as the number and as long as the multiplier is right up in front of the bracket, in other words, no pluses or minuses, that does not mean multiply, that means combine. This one means multiply. You could have a bracket around both of them. As long as those brackets are side by side, that always means. Or you could even have a bracket around the first one and not the second one. As long as it's touching a bracket, if it's touching a bracket, that always means multiply, no matter where it's located. But the most common way of writing multiplication in algebra is just to write the letter and the number side by side. And you can do this with letters too. A, B, C literally means A times B times C, right? So we've talked about these operations before and how algebra changes the operation. What you need to remember, though, is that multiplication is the only operation that requires no symbol. Well, let's put operation symbol. So if you don't see pluses, minuses, or division symbols, fraction bars, or x's, or whatever, then you just assume that it's going to be multiplication. So we've refreshed our minds a little bit about what operations look like and how you can write multiplication when you're dealing with algebraic expressions. Now let's go talk about how we would actually do the multiplication if we're multiplying. So to multiply algebraic terms, if you remember, all algebraic terms have how many parts, guys?
4.
4 parts, exactly. And you might notice that I keep reminding you of that. And the reason I keep reminding you of that is that if you know the 4 parts, then you're always going to know the process to use, right? We always look at the sign first. We always add or subtract or multiply or whatever the numbers. We always keep the base or do something with the base. We always work with the exponents last. So if you always keep that in mind, those 4 parts and the order in which they occur, then you're always going to know the steps for working with these, okay? It's really important that you just own that, It's got to be part of what you do. So the first part of every term is its sign. And so when we're multiplying, the first thing we're going to do is determine the sign. Now in the work we're going to do today that you're going to see Everything is always positive, so it's not so important because if they're both positive, the sign is going to be positive. But just for your own sake, I want to remind you a little bit about the rules. If the signs are the same, the answer is always a positive when they're multiplying, right? If the signs are different, the answer is always a negative. Now, that's not the same as the rules for combining, so make sure you remember it. That's one of the reasons why we have to pay attention to the operation symbol that's given, so we'll know what sign rules and what other rules to use. Okay, so first thing you would do is determine the sign. We're not so worried about that today because everything's going to be positive, but remember, we have to have signs between things, so we're still going to determine the sign first. Second thing you're going to do is you're going to multiply the coefficients. Now remember, coefficient is just a fancy word for the multiplier. In a term, it's always the number parts, right? So the numbers. So multiply the coefficients, the numbers. And of course, you'll multiply like you always have. 3 times 2 is still 6, hopefully. Right? So you'll just multiply those coefficients. Third step, you're going to keep the base. So in other words, if it's an x times another x, you're still going to get an x as your base, right? Multiplying the coefficients won't change the base. And here's what's new. You're going to add the exponents. And we're going to talk a lot about why you're adding those exponents. It's an algorithm. It's a shortcut. And we're going to talk about why, but I want you to get this down. All right. So before we start multiplying any of these, the first thing I want to do is I want to talk about this bit here. Why are we adding those exponents? And so let's just go to an example and I'm going to show you why are we adding exponents. If you think about x to the second, oops, sorry, I'm changing. I'm going to do y's. Y to the second times y to the third power. When you have exponents, remember that exponents mean repeated addition, right? So what we could do is we could expand that. Y to the second would become y, times another y. Remember, y to the second literally means y times itself, another y times a y. You have 2 factors of y. Times, that's that multiplication right there. Y to the third is y times itself 3 times. And if you count those up, 1, 2, 3, 4, 5, that means we would have y to the fifth. Sorry, was there a question?
Could you just slow down a bit?
Sure. So if you look at the answer we got after we expanded it and just counted them all, we could just take those 2 exponents and add them together, and that gives us the same answer. Now, you could, every time you do one of these, write it all out and then count up how many factors of y you have. Remember, factors means things that are multiplied together. But it would take forever to do. And especially if you had something like a to the 15 times a to the 20. It would take you an entire sheet of paper to write all that out. And besides, a lot of time and that you don't have. So instead, what we can do is just remember that when we're multiplying bases, the same base with exponents, what we can do is simply add those exponents together and get our answer.
Mr. Sell, can we only add the exponents if the variables
Yes, that's a great question. You can only add exponents on like bases. Now, not like terms, but like bases. Excellent question. Guys, can somebody mute their mic? If you're so like bases brings us to another question. What happens when we have more than one letter? So say we have a to the third, b to the fifth, times a to the second, b to the third. Who cares? Doesn't really matter. Our operation here is multiplication. And so what I'm going to do is, and I'm multiplying with algebraic expressions. So what I'm going to do is I'm simply going to combine the bases, add the bases, the exponents on like bases. So that becomes a to the 3 plus 2, b to the 5 plus 3, which is a to the 5th, b to the 8th. Now I couldn't add the 5 and the 8 together because the bases are not the same. I don't know what those letters are, what those numbers are that the letters stand for, so I can't simplify it any further. So there's your answer for that particular one. Okay. Now I'm going to give you a piece of advice. Do you see here that I wrote out the addition? Now, not all of you are going to need this, but if this is new to you or you don't remember it, what I want you to do is I want you to write out the addition. Now, because when we switch operations, this addition is going to become subtraction later. We're also going to have signs thrown in there at a later time. You don't have to do it forever, but while you're learning it, until it really, really sinks in, if you write out the addition, the more time you write out that addition, the more likely you are to remember it. Okay? Again, I know you don't like to do extra work or take extra steps, but it will save you from having to do extra work and taking extra steps later in your life. Yeah? Makes a big difference. All right. So let's look at at multiplying some terms, some examples of multiplying terms now that we know all the processes. All right. Now, let me tell you that. So if you wanted to show multiplying these together, you do not need any, oops, sorry, that's supposed to be an a squared b to the third. That means multiply as well. You won't see it as much like that because generally we have terms. But, well, you just look at...
How would you know to... Because the a and the b are together, so what if you accidentally end up multiplying the a and the b and the other a and the b?
Well,
and then wouldn't it get confusing?
Right, that's part of learning the rules and making sure that you know that's part of learning the rules and making sure you know the rules. So if it were stacked like this, I would only be able to add the exponents on the like bases. And again, that's just part of learning the rules, which is where I'm going right now. So the most important thing that you can do is focus on those rules, those steps. If you know the steps, right? So let's put in add the exponents on like bases. Okay, so if you know the steps, then it's less likely you're going to make simple mistakes like that. So that's why I keep coming back to this. Make sure that this is the part you study. This is the part you do. It is important that you practice, obviously, but the practice is not as important as the steps. If you did nothing, no practice at all, but you memorized these steps and you knew what each one of them meant, you would be better off than if you did a ton of practice but never learned these steps. If you know the steps, because this is nothing new, this is add, subtract, multiply, and divide. This is operations that you already know. So if you did nothing else but learn these steps, then you'd be miles ahead of someone who didn't, even if they did a ton of practice. Okay? So keep that in mind. This is the important part. Learn the process. If you know how to do something, then the chances of you being able to do it are greatly increased. All right, so let's go to the book and look at a couple of examples of these. And I want to use their examples just to see how everything is written so you'll see what you'll be doing. Okay? So let's pop to the book. Here we go. So exercise 7E on page 153 is where these are. So we'll just start with, and so remember that you're going to take it step by step, and you're going to have algebraic terms. Yes? What now? Did you have a question?
I think she was trying to say that you were glitching for her.
Okay. All right. Okay, so let's look at the first one, A. So we have 4C times 2. Now, be careful. We always need to identify the operation first. So our first step is, what operation do we have? And that's pretty easy here. What operation do I have there indicated by that X?
Times.
Times or multiplication, you bet. Good job. Okay, and we need to know what we're working with, because remember, we have numbers, which are called constants, right? We have fractions. We don't have any fractions in this particular exercise, but we do have fractions. We have algebraic terms. So the building blocks of our mathematical system are getting bigger. So we always have to ask what kind of things we're working with. And because we have this C in there, we know we're working with algebraic terms, right? So make sure you remember that, because multiplying 4 times 2 is just arithmetic. But because it has the C in it, we have to pay attention to what rules, okay? So then we need to know the steps. Because they're algebraic terms, the first thing I need to do is determine the what? Sign. But it's a positive times a
Sign, coefficient, basic.
Yeah. Okay, well, let's do one at a time there. So it's a positive times a positive, so it's going to stay positive, right? And that's going to be the case in all of these, but okay. Second thing we need to do is multiply the coefficients. And my coefficients are just the numbers, right? So the coefficient of the first term is a 4, and this one is a constant term. I can multiply algebraic terms times constant terms. You can multiply anything. Now, I wouldn't be able to combine these because they're not like terms, but like terms has nothing to do with multiplication. Everything can be multiplied together in some way. So I'm just going to multiply that 4 times that 2. So whatever those coefficients, those numbers are, they get multiplied together. Then I'm going to keep the base. So my base is a C, so this thing becomes a C. And I'm going to add the exponents, but do you see any exponents? No, all we had was just a plain old C, so our answer is just going to be a plain old C. So even though this was a C term and a number term, they can still be multiplied together.
Please.
Pardon me? Yep.
May I have a bit more?
Okay, so there we are. We multiplied that one. Let's look at another one. Say we have, let's look at G, for example. So we have 8t times 6c. Now again, first thing we need to do is identify the operation. And here we have an operation symbol, so we know that this is what, guys?
Multiplication.
Multiplication, excellent. We need to know what kind of things we're multiplying. And since we have T's and C's in it, we know that these are algebraic terms. Yes? So we need to go to our steps for multiplying algebraic terms. The first thing I need to do is determine the sign, but it's a positive times a positive, so it's just going to stay positive. Now remember, you don't have to write that plus down, but it's not going to hurt you if you do. Then we're going to multiply the coefficients, which the coefficients of terms always just means the number parts. So we're going to take 8 times 6, which is going to give me 48. Then we're going to keep the base. But do you notice that I have 2 bases here? So therefore, I'm going to keep both of them. But watch how I write them when I write them down. I'm not going to write TC. Instead, I'm going to write CT, because if you'll remember, when you have more than one base, you always write them in alphabetical order, and that still holds true. Now, it wouldn't be wrong if you wrote TC, but it's just better form if you wrote CT instead. Okay? In the back of the book, they may have written it as TC, but I want you to get in the habit of writing them always, if you have more than one letter, to write them in alphabetical order. Now, There aren't any exponents on the t and the c, so there are no exponents to add. So my completed answer is just positive 48 ct. Oddly, and I'm going to give you time to write in a minute, oddly, these simple ones are the hardest ones for students to grasp because you're multiplying some things, but you're not following every rule. But remember, if all the pieces aren't there, then you're not going to use all the rules. So keep that in mind. So as you go, when we drop down to the bottom, the ones that look more difficult are the ones that students deal with better. It's the simple ones. So focus on those simple ones. Okay, so let's look at something like f. We have, So f, we have x to the second times, since they're x's, I better write them funny, 4 x's. Okay? This is why in the States we use the dot so that you don't get it confused with the x's, but it doesn't matter. One way is not better than the other. But if I get confused and use one instead of the other, you'll know why. All right, so first identify the operation. Our operation here is multiplication. We have x's, therefore we know that these are algebraic terms. So to multiply algebraic terms, the first thing I do is determine the sign, but it's a positive times a positive, which remains a positive. Then I multiply the coefficients, but I don't which means the number parts of the term, but I don't have a number in front of the x squared. If there is no number in front of the x squared, what do I assume it to be?
1.
1, excellent.
1.
So I'm going to multiply 1 times 4, which just, of course, stays 4. Then I'm going to keep that base, and they're both x's, so I'm just going to get a base of x. But this time I do have exponents, so I'm going to not multiply them, but what?
Add them.
Add them. Good. And my first exponent is a 2. What is my exponent when I don't have one over here?
1.
Also a 1. Good. And if you want to write those ones in to make it easier on yourself, do it. All right? So that means I'm going to take the x to the 2 plus 1, which gives me x to the third. So there is my completed answer. Okay. Another one that I want to show you is I want to show you something like, look at G. Now, we've done this before, but you may not remember. That doesn't mean it's been a while. So what we have here is we have a bracket. And that remember that we always have to deal with brackets first. And if you have an exponent on a bracket, that literally means to take the entire bracket times itself. Do you remember that, expanding those brackets? It's been a while. Okay? And you must expand them. Do not use any shortcuts here. Now, there is one. I don't want you using it. I want you to expand the brackets, because if you try this shortcut, this is one of those shortcuts that really, really makes students have problems in the future. So just expand it. It didn't take me 2 seconds to rewrite that as 7x times 7x. So now, because they're right beside each other, that means multiply. So we'll start multiplying with the signs. Positive times a positive is still a positive. Then we'll multiply the numbers, or the coefficients. So 7 times 7 is 49. And we have like bases, so we can combine our exponents on our like bases. Since our x's don't have any exponents, we assume them to be 1s. So that's x to the 1 plus 1, or x to the second power. And there's your completed answer after you have expanded the brackets. Okay, look at something like, I don't know. How about p, just because it looks ugliest? Again, the process never changes. So if you learn the process, if you learn the rules, then you're always going to be able to do these, right? That's the most important part. That's the key to making everything else work. Oops, sorry, X, funny. Okay, first thing is, the most important thing is identify the operation. Here I'm multiplying. Then I need to decide what kinds of things I'm multiplying with. These are definitely algebraic terms because you have the letters in them. So we go to our steps for multiplying algebraic terms. It says first I need to determine the sign. So it's a positive times a positive, so it's still a positive. You don't have to write that plus, but it's a good idea. Trust me. Then I'm going to multiply the coefficients, and coefficients of terms just mean the number parts. So I'm going to multiply the 9 times the 7, which gives me 63. Then I'm going to start combining or adding the exponents on like bases. Here I have an x term. There are no x's in this one, right? So that means that x to the second is just going to stay the same. But this one and this one both have a y in them, so that means I'm going to take that y and keep the base and add the exponents, so that's going to give me y to the second. And there's my completed answer. Piece by piece. Don't try to look at it all at one time. Later you'll get so used to this because you're going to do it a lot that you can just look at them and say, boom, 63 x to the second, y to the second. But for now, write it out. Take it piece by piece. Learn the steps. Okay? All right. Well, so you've seen some examples, but the most important thing, though, is to learn the steps, the process. So I'm going to give you some work to do, some homework. If you're having difficulty learning the steps or memorizing the steps, remember, do what I did on the side there, right? Where I...
Oh, it's doing a Kahoot.
Not today. We're going to do the revision as one. So maybe tomorrow or next time. Okay? So here we go. So make sure you learn those steps, okay? Be really sure that you've learned the steps. Now, so what I'm going to do is I want you to give you an assignment. I'm going to post this on your OneNote. I'm sorry, on your Teams. We have so many different platforms. Post this on Teams because I want to see these again. So you're going to practice your uploading skills again. So we're going to do exercise 7E. It's on page 153. And it's 1 and 2. Numbers 1 and 2. It's the only thing we have there. And I want you to do them all because these don't take very long, but you need the practice, right? Remember, if you don't see a number, you assume it to be a what?
A 1.
A 1. If you don't see an exponent, you assume it to be a what? Also a 1, right?
1.
So put those in if you need to, just like I did here on the y's. I put y to the 1, y to the 1. Okay? All right. Stop the recording.